the chain. This was the previous thing that was in the video. And in my opinion, the average rate of change is actually quite straightforward. Most problems involve just plugging into the formula. And the formula, I will refresh your memory, is this. F of b minus f of a divided by b minus a. This is the average rate of change from x equal a to x equal b. And if I give you a specific function and ask you to find me the average rate of change, all you got to do is plug in the numbers and such to that formula there. So for example, just a little refresher memory, if I said, f of x equals 3x squared plus 2, find the average rate of change from x equals 1 to x equals 3, say. All you do is plug these things into the formula. You have to decide what is the f. Well, the f is this. This is the function. What is the a and the b? They are these two numbers, which are these two numbers. And typically, I'm going to use the smaller number for the a and the bigger number for the b, although it doesn't actually matter. As long as you're consistent, you can do it either way. But I'm going to use a equals 1, b equals 3. And so the average rate of change formula looks like f of b, which is f of 3, minus f of a, which is f of 1, divided by 3 minus 1. That's just plugging in the a's and the b's where they go. And then what does f of 3 mean? It means you go to this function and you plug in 3 to this function. So this, if I were to just stick it right in there, f of 3 means you do 3 times 3 squared plus 2, right? This right here is f of 3. It means you go back to this function, you plug in 3 instead of x. So it's that, and then I go minus, just because that's part of the formula. F of 1 means 3 times 1 squared plus 2, right? And then all of this divided by 3 minus 1. And now it's just a bunch of numbers, and you can figure out what all the numbers are, and that's all there is to it. I hope, by the way, if you're writing this down like I am, I hope that you put parentheses in here. I know some people out there are, I've heard that there are some parentheses haters out there. I don't so much personally mind if you're a parentheses hater, but if you don't draw these parentheses, you may forget that this minus sign has to distribute here, in which case you'll mess it up. So I would suggest that you embrace the parentheses. That's what they're for, isn't it? For embracing all of us. Don't be a parentheses hater. Or at least hate responsibly. If you want, for some reason, you just don't like drawing parentheses, you better remember to distribute minus signs appropriately. My suggestion, just write the parentheses. I don't know why you wouldn't. Just because you're being a hater, I guess. Anyway, can we just finish this off? So I'm going to do all these numbers. 3 times 3 squared, this is 9 times another 3 is 27 plus 2, that's 29 there in the first parentheses. And then the second one is 3 times 1 squared. 1 squared is 1. So this is 3 times 1, which is 3 plus 2 is 5. So that's a 25 minus 5 divided by, on the bottom 3 minus 1 is 2. So I guess this is 24 divided by 2, which is 12. That's the answer. All right. I say the average rate of change is easy to do. I mean, I suppose it took me a few minutes to do this, but that's because I was talking about other things at the same time. And really all it is plugging in a bunch of numbers and you get some kind of answer. You don't have to think very much to do problems like this. I hope you agree. Any questions about that? Great. The instantaneous rate of change is what I really want to talk about today. And it is related to that, but as I said, much more complicated. So the instantaneous rate of change, also much more useful in the real world. Instantaneous rate of change. So the idea behind the average rate of change is this is meant to represent how something is changing over a certain duration of time. Like I could ask something like, has the economy gotten better in the past week? What I'm talking about is, what's the change like in the economy from this day to this day? That's an average change over some duration. What we're going to talk about today is called the instantaneous rate of change. This is when I ask you about how is something or other changing right now, not over some kind of long duration, but at a particular instant This would be useful for, I mean, it's useful all the time, but a simple example would be something like, how fast is my car driving right now? What I mean is just tell me what the speedometer says. I don't mean something like, okay, after the last hour, what was my average speed over the duration of the last hour? That's less interesting than just, what is the speed right now? That's usually what I care about, if I care about the speed at all. In that case, the instantaneous rate of change is a lot more useful than some kind of average rate of change. So we have to think about, what does the instantaneous rate of change even mean? Like if I ask you, right now, is the economy, how is the economy improving right now? You might say, well, you mean like over the last month? I say, no. Right now, like right now. Not even like over the last hour, just now, precisely now. You may, if I say this enough times, you might ask me like, what are you even talking about? Or what does that even mean, right now? But of course, there is such a thing as right now. Like my car is going a certain speed right now. Like that is something that makes sense. So there is such a thing as an instantaneous rate of change, even for more abstract things like the economy or whatever. And here's how we imagine them. I'm going to draw a little picture about, so here's a picture related to the average rate of change, which is a simpler concept. The average rate of change, if you recall, is something like this. And if I ask you about, here's the A and the B, they have their own points on the graph. And if I ask you about the average rate of change, really what I'm talking about is this slope right here. You could imagine this sort of big line here. What does that have to do with the average rate of change? It's because these y values, if those are a and b, the x values, the y values would be f of b and f of a here, right? The distances between these points, I mean not the diagonal distance, but like the horizontal and the vertical distance. The horizontal distance, of course, is b minus a. That's just, it's this distance on the picture. The distance between two numbers is you subtract them. And then the vertical distance, similarly, is the difference between those two numbers. So this distance here, the vertical distance, is f of b minus f of a, right? And so the slope of that black line is the rise over the run. And what are the rise over the run? The rise and the run are those two things that I wrote. The rise is the vertical one, and the run is the horizontal one. And so this slope equals the average rate of change. And it is this, it's the rise over the run, which is this old formula, f of b minus f of a over b minus a, all right? This is the point of the average rate of change, okay? So this is the average, not the instantaneous. What about the instantaneous? To get the instantaneous, sorry, I'm running out of room here. The way that we're going to consider the change right now, not over some duration, but at a specific instant, the way to consider that is you can imagine it's like a duration, only that duration is kind of like infinitely small. And the way technically to do that is you do this whole thing, but you do the limit as b approaches a. Then this interval here, this duration of time, if you will be kind of infinitely small if the b and the a get very close together. So to get the instantaneous rate of change, we do lim as b approaches a of all that, of the average. I'm just going to draw what the picture would look like in that case. So this would be the picture. I'm going to try and draw the same picture, only this time the a and the b are going to be very, very close together. Like right next to each other, if that means anything. Maybe I'll draw this. And let's say the A is here and the B is here, like right next to it. Oh, my pen is acting up again. Like that, right? If the B and the A are really, really close together, then I can still draw like that slope, that line. In this case, it would look something like that, right? A line which goes through both of those points. All right? And now, if you can imagine the B approaching the A even closer until they become like indistinguishable points, as B approaches A, sort of infinitely close down here, this line actually looks like there's sort of a name for this line. This will become a line which touches the curve in only one point. Anybody seen that before? There's a name for that. The slope approaches. Anybody know what I'm talking about? It's a line where if you have a curve and a line is like this, and the line which just, I dropped it, that's why I don't do the chalk, just barely touches it at one point. Anyone seen this before? There's a name for that. The T word. This is called the tangent line to the curve. Maybe you heard that before. It's a line which just touches the curve in a single point, and does not touch the curve in any other nearby point. The slope approaches the tangent line to the curve. That is a line touching only in one point. All right? This is how you can talk about the slope of a curved line. Probably like when you're in high school, typically you learn how to talk about the slope of a straight line. Everybody knows the slope of a straight line is the rise over the run. But on a curvy line, it's hard to say exactly what does the slope mean. It means this. When you look at the tangent, you take the slope of that line. Yeah.
Scroll for a second. I didn't get the.
Yeah, sure. So the point of this is what we have to do if we want to discuss the instantaneous rate of change. All right. And so I will write a formula for this. It's just the same average formula, but I put a lim in front. That's all it takes, really. To get the instantaneous, as I said, you do this limit of the average. So the instantaneous rate of change is lim B approaches A, f of B minus f of A over B minus A. All right. This is a formula. Now I'm gonna tell you to memorize the formula for the instantaneous rate of change, but actually it's not this. We're going to use a simple variation on this, which I will put in a box and tell you to memorize. But this is the basic idea of it. It turns out to be a little bit easier to use. So this is called the instantaneous rate of change is this. This is a little bit easier to use, although it might look a little more complicated, but it turns out to be easier to use. If we call the points, instead of B and A, we're going to call them A and A plus H, where you imagine H is like a little bit. So I'll just draw the picture one more time using A and A plus H. This is how we are typically going to write this formula. A and A plus H, where you imagine H is some like little bitty bit which separates these 2 points. And then instead of saying lim as B approaches A, we do lim as H approaches 0, because H is this little bitty bit distance between the 2 numbers. All right? So this is it's exactly the same, it's just I'm using slightly different labels for things. Instead of the A and the B, I use the A and a number very slightly bigger than A, which is A plus H. All right? And I'm going to do the limit as H approaches 0. So our true formula for the instantaneous rate of change, this you should put in a box and memorize. The instantaneous rate of change, I'll write it like this, of f of x at x equals A. The A is important. This is at a particular instant, and you can say whatever instant you want. That's the point which is called A in this formulation. The instantaneous rate of change at x equal A is written like this. This is a little strange, but this is the way that we write the instantaneous rate of change. Anyway, it is lim h goes to 0, like I said. And now over here I'm going to write that f of b minus f of a, but remember I said instead of b we're calling it a plus h. So it looks like f of a plus h minus f of a divided by, on the bottom should be b minus a, but instead of b it's a plus h, so it's a plus h minus a, but then the a's cancel and it's just h on the bottom. So this is the formula for the instantaneous rate of change. And you should memorize this. I'm not big on asking you to memorize things. Like over the course of the semester, there's not all that many formulas to memorize, but this is one of them. All right. Hopefully, we're going to be like doing enough examples that you won't have to ever sort of sit down with your flashcards and remember it. Okay. Let me just say, on the left side of the equal sign there, this when you see this, this is pronounced like f prime of a. This little thing here is a prime. So when you see that, you say f prime of a. And it's very different from f of a. F of a just means you plug the number into the function. F prime of a means the instantaneous rate of change at that particular instant, which is a much more complicated thing. It involves this whole formula over here. All right? Let's try some examples. The typical problem about instantaneous rate of change is like I give you a function and I tell you what the a is, and your job is to find the instantaneous rate of change when x equals a. Let's start with an easier one. There aren't ones which are completely easy. These, as I said before, these are much more complicated than average rate of change. In my opinion, this is the most complicated thing that we've done so far in the semester. How about this? For f of x equals x squared plus 1, find f prime of 3. All right, f prime of 3 means the instantaneous rate of change at the point a equals 3. All right. Don't think too hard about this yet. I'm just going to plug into the formula up there where I'm using, sorry you can't see it, I'm using a equals 3, right? That's all I got so far, but we can write that down at least. F prime of 3, maybe I'm gonna back that up. F prime of 3 is, okay, lim h goes to 0. F of, I'm using 3 for a, so it's f of 3 plus h minus f of 3 divided by h, all right? What do we plug in for h? The answer is you don't really plug anything for h. H is just another variable. Eventually, we are going to do this limit by making h 0, but we can't do that yet. We'll have to simplify this quite a bit before you can actually do the limit. One of the last steps will be to plug in h equals 0, but we're not there yet. All right, this is the start. And now immediately you get a hard step. This is something that you'll find yourself when you're trying to do this on your own. Some people get just totally stuck immediately here. What is f of 3 plus h? So I'm trying to simplify now, or at least plug stuff in. F of 3 plus h. So f of x is this. What does it mean when I say f of 3 plus h? It means I plug in 3 plus h to this function. That means you look at this function, wherever you see x, you write 3 plus h instead. So instead of x squared, I'm going to write 3 plus h squared. And I'm going to put parentheses, because I'm a good boy, and I always write my parentheses when appropriate. And then plus 1. So what I've written right here is just this piece right here. F of 3 plus h, it means you go to the function and you replace x by 3 plus h, because that's what f of always means. It means you plug in, instead of the x, I plug in something else. And in this case, I'm plugging in 3 plus h here. That's why it says, instead of x squared plus 1, it says 3 plus h squared plus 1. All right? I don't know if that looks hard. You will find this is very confusing when you're trying some examples. I'm going to do this one and then one more, and then I got some for you all to try. All right? What's next? Minus is next, okay? Minus. Then f of 3, this is a bit easier because f of 3 just means you plug in 3 to this function. So I am going to put my parentheses here and plug in 3 to the function. It will say 3 squared plus 1, right? That's this function, but with 3 plugged in for x. Sorry, I'm a little bit off the top. All right? So that part, if I were to sort of draw these little boxes, that's this part, right? And there's a minus sign in between them. Okay? And then on the bottom is just h, and there's nothing really to do with h at this point. I just leave h like it is, all right? And the way we're going to do this limit is by simplifying until eventually we can cancel the h on the bottom out. Simplifying in this example means doing the FOIL thing up top. I see 3 plus h squared. So I'm going to do the FOIL there. Maybe I'll just write it out. 3 plus h times 3 plus h. And then all this other stuff is still there. Plus 1 and then minus. Can I do inside the parentheses? 3 squared plus 1 is 10, right? 3 squared is 9. Plus 1 more is 10. All right. Over h. All right, I'm just going to keep on simplifying here. Multiply this out. 3 plus h times 3 plus h. That's like the FOIL thing. The first thing is 3 times 3, which is 9. In the middle, I got 3 times h. And on the outside, I got another 3 times h. Those you can add up to make 6 times h. And then on the end, I got h times h, which is h squared. And then I also have plus 1 minus 10 divided by h. All right? And now this thing is as expanded as it's going to get. Now I want to cancel some things out. Does anybody see something I can cancel there? Yeah?
10s, 9 plus 1 and 10.
Yeah, these constants, I got 9 plus 1, which is 10, but then minus 10. Those actually cancel completely. So I'm going to cross them out. This, when you're doing these examples, this is a very good sign that all of the constants cancel. In fact, if you do it correctly, the constants will magically cancel out. If the constants don't cancel for you, it means you messed it up somehow. So what's left is 6h plus h squared, right? That's all that remains on the top. What can we do with this, or a question?
Couldn't you take out the h on the bottom?
Take out this h, cancel it with something?
6h.
Yeah, this is not, you do want to cancel the h, but you can't do it in this step because these guys, well, how about, can we just look at it right here? It is not legal at this point to do this. These crossies are not okay because when you want to cancel something in a fraction like that, it has to be something which is multiplied, not added. Sometimes people call this slashing. No slashing. I don't really like saying that because sometimes you can cancel them, just not in this situation because they're added up top. Anybody have another related suggestion? We can do something here which will facilitate actual legal canceling. Yeah, factor the h out on the top. So both of those things have h's on them, which means I can factor the h out, and then you are allowed to cancel it. So what remains is 6 plus h like that, h on the bottom. And now because it's being multiplied up top, I can cancel them like this. We're just about done at this point. H goes to 0 of 6 plus h. And now finally, I have been writing lim every time. That's because this is an operation which I have not yet been able to do. But at this point, we can actually do it. We plug h equals 0 in. And my final answer is 6 plus 0, which is 6. That's it. All that work just to get a simple looking answer like 6. But that's how you got to do it in these. Anybody got questions about that one? It is a little complicated. That was an easy one, actually. Let's try one that's a little more complicated, and then I got some for you all to try. Are we ready? Let's try. Let's do, let's find f prime of 2 for f of x equals 3x squared minus x. All right? Or if you prefer, here's another way that I could ask this question. find the instantaneous rate of change for f of x equals 3x squared minus x at a equals 2. This is another way that you might see that the same question is written just kind of in words, but f prime of 2 means instantaneous rate of change at the point 2. So these are the same question. Anyway, you don't have to think too much to begin. You write down the formula which you have remembered. F prime of 2 is lim h goes to 0. It's always f of a plus h, or in this example a is 2. So f of 2 plus h minus f of a divided by h. That's my instantaneous rate of change formula. Yeah?
Can you scroll up a little bit?
Yes. Yeah, sorry about that.
Close the door too.
This thing is unhooked. All right. Okay. The first step is the plugging in, and this is the step in which you are liable to get a little bit confused, but hopefully we can handle it. The plugging in means f of 2 plus h. What that means is I go up to the formula for f. I write this same thing again, but instead of x, I am replacing x with 2 plus h. So it begins with 3, followed by, not x, but 2 plus h squared. So this looks like 3 times 2 plus h squared minus 2 plus h. So that stuff here is that much of it. Where does 3 come from? It's because this is the function I'm plugging into. So it begins with a 3. Then you have x squared, but I'm using 2 plus h instead of x, so it's 2 plus h squared. And then it has a minus. And then it has x, but instead of x, I'm using 2 plus h. So it's like that. And you better put those parentheses because the minus sign is going to distribute and mess you up if you forgot the parentheses. All right? Continuing, this is that's only this part, right? So the rest of it, minus. And then f of 2. This is quite a bit simpler. It just means you plug 2 into the function. 3 times 2 squared minus 2, like that. All of this divided by h. All right. That's the plugging in step. Let's continue. So we're going to do similar things that we did in the previous example, which is like distributing a lot of stuff. So I have 3 times a FOIL thing. I will leave the 3 alone for now. It's like that. And then minus 2 plus h. Let's distribute the minus sign. It says minus 2 minus h. And then minus the number inside the parentheses there. I like to just figure out what the number is. 2 squared is 4. So this is 3 times 4 minus 2. That's 12 minus 2, which is 10. So this is minus 10. All divided by h. How am I doing so far? Okay, great. Thank you for the encouragement from one of you. All right, let's continue. What can we do next? Let's do the FOIL thing on the 2 plus h and the 2 plus h. That 3 we're just going to have to leave there for now. It's not convenient to try to multiply the 3 also in the same step. So I'm going to leave 3 like it is. And now 2 plus h times 2 plus h. On the front, I got 2 times 2, which is 4. In the middle, I got 2h. On the outside, I got another 2h, so they add up to 4h. And then on the ends, I got h times h, which is h squared. And then the rest of this, minus 2 minus h minus 10 over h. And then finally, the last sort of act of expansion, I can finally distribute that 3. And then we'll be ready to combine and cancel stuff, hopefully. So distributing the 3. 3 times 4 is 12, plus 3 times 4h is 12h, plus 3 times h squared is 3h squared. And then what we got, minus 2 minus h minus 10, h on the bottom. And now we can start just canceling things. Anybody see something you can cancel or combine? Sometimes they don't cancel, they just kind of add together and you can combine them. But yeah.
12, 2, and 10.
Yeah, all the constants will cancel, and this, like I said before, this should always happen. All the constants should cancel. I have plus 12, minus 2, minus 10. That all adds up to 0, right? So they can just go away entirely. I see one more thing that can kind of combine, although it doesn't quite cancel.
Is the H in the denominator, the H in the numerator?
You cannot do that kind of canceling. Just like I said in the previous example, this would not be allowed at this point.
The other one on the right.
This one?
Yeah.
Yeah, it's the same issue. It's because the stuff up here is being added together. You can only cancel when it's multiplied, not added. I saw somebody, no?
Yeah,
Yes.
12 minus H.
Yeah, you can combine the 12H and the H. So this here and this. 12H minus H, they add up, you get 11H. The rest of it is just 3H squared, which you gotta leave like it is. Okay. 12H minus the H gives me 11H plus 3H squared divided by H. All right, it's getting a lot simpler. What can we do next? At this point, actually, it looks very similar to the previous example. You see the format of the previous example was this, right? It's very similar, but with different numbers. What do you want to do now?
Factor up the H.
Factor the H in the top. Yeah, this is kind of always how it goes at the end. Factor H on top. What remains is 11 plus 3H on the bottom H. And now, finally, we can cancel the H's because H on top is being multiplied, not added. All right. And so all that remains is 11 plus 3H. And we finish by plugging in H equals 0. 11 plus 3 times 0, which is 11. The end. That's how we do it. The answer should always be a number.
For
Yep.
all these, are we gonna have H is 0?
Yes, the reason I used H is 0 here is because I'm doing the limit as H goes to 0.
Okay.
And that's part of the original formula. So it's always going to be 0.
Okay, thank you.
Yeah.
Can you scroll down?
Yeah. All right, I got some for all of yous to try to see how you like it. It always, I think, at least people tell me, it always looks easier when I do it. A little harder when you got to do it. All right, let's try. How about? It's going to be, similar steps here. F prime of 1 for f of x equals 2x squared minus x. And I'll give you 2 of them, just for funs, for the lols. The answer of each of these is a number. It's a lot of equations, complicated equations, but it all should boil down to a single number at the end. And I'll tell you, the first one, the answer should be 3, just so that you know if you did it right in a few minutes. And I believe the second one is 10. I'll give you a few minutes to get it started, and then I'll come around and see how you feel.
So I have to put this, so that, so you get, it's probably 2 times.
Oh, yeah, that's good. This, regional format. Oh. Okay. So for the, okay.
Yeah, that's the one.
So if we write this one out again, then instead of X, and this here you should put this selection should choose just, just like this. Yep, this is good. This is not quite, so you want to write this one
Oh,
now.
so it's 2.
Which are the two squares? 2, and then 1 plus h squared. Yeah, and then this. Minus 1 plus h, because you replace x. This is this. And this isn't everything, that was only this part.
Okay.
And this. Press down, yeah, that's pretty good. Yes, that's pretty good. Okay. Mm-hmm. Yeah, okay. Alright. 8, 11. Nice. Oh, that was good.
Yeah, yeah.
1 plus h squared minus 1 plus h back. That minus 9.
Okay, and so it's like minus eight.
Now you
Okay.
change things. How's it going?
I'm a little stuck. Does this look good?
Yeah, yeah, this is good.
Okay.
There should be parentheses around.
Parentheses right here.
Yeah, that whole thing used to be
Okay. And then my next step.
That matters.
Okay. So then my next step after this will be what? Cancel these?
No, you can't say this. This is a being
Uh-huh.
So you would do the 4 lines.
Oh, okay. Thank you.
Steph, how'd you get from here to here?
Yeah, that's the hard step at the beginning. You f of 2 plus h means you do this formula for f, and so that's like
So wait for this like
yes, that's where this comes from.
and then you're like
So
that.
f of something equals 3 or 4.
What is the third one plus h after you?
And then
How do you do?
Show me when you have
This part is
So I'm on the first.
like 2.
okay, so this would look like
You're only playing
Yeah,
So the third one,
this is what I
yeah, one h, the 1 plus h squared minus 1 plus
Yeah, so you mean, I was wrong. I was gonna say you mean that's okay, it's right. And replace f by 1 plus h, and 2, and 1 plus h squared, and then minus.
Yeah, I have that same.
How's it going?
I think, and then you can multiply.
Yeah, so you
The two after the
so the very first step is what you do.
Where'd you get the 2? I only have the 1. No, the 2. The minus 2 minus 1. So she added that up.
Yeah, you do this too.
Yeah, please no, I don't want to read it.
Yeah. So that was just this part. How's it going? Yes, you only wrote part of it. So you had to do So if you begin like that, you do f plus 1 plus h. There's other stuff. One is f1.
does this look right for that part?
Yes.
Question? No, you're fine. I'm just one number off by the second one, 11, and
11.
I'm not sure why I messed up.
Could, maybe I missed it.
Because I have the H's, like the single H's right here, and it was plus 4H, and I multiplied the 3, and so it's positive 12H, and then that was the second one became a negative, if that makes sense. Like right here, it's not helping me right here. This H right here is a negative, so when I got to the positive 12H, this one became negative. Or it became 11, so not
Possible it should have been under the receiver branch. Because that's what I.
Oh, yeah. Sorry, right here.
One last switch.
Okay.
Is this?
lost the-
Typically you would throw it to this part. That would be
Yes.
18. I don't think I did that.
Yeah, there shouldn't be any minus 1.
No, okay. Alright, that's fine.
Looks like people are doing all right. I'm gonna come around again. These are.
I'm working through it, but I kinda like thinking myself.
All right.
Okay.
How's it going? How's it going? You got your three? That's like,
What do you mean by?
Distribute them.
I don't know what that will do.
Like distribute them.
I have this on the three. Yeah, would it be like -1
I
minus 8?
didn't multiply the -2 with the H.
Probably full of material.
I don't have that capacity.
Super awesome way to use this.
It's always like,
Yes,
I
so
know
we're gonna do that. So
Is this right?
That's right.
Look for what I'm talking
Yeah.
about.
It's gonna be 2 times.
I'm trying to like figure out.
Alright, forget it, forget it.
Oh, well. Okay. You go.
You should be plugging this into that.
Oh, okay. So 5 minus 2.
Okay, I don't know.
Okay?
If this is-
Okay, yes,
It
so
should be
what
like
type
this.
of
It should have like minus 1 plus H minus 1.
You do the formula, which is here for that. But
Like this should have simplified to just -1. This will go to like this right here, 'cause it's, so
So
what's
let's
two,
write
then
x raised to this plus
you would
Be correct.
plus 2 plus
Yeah.
H. No, then this also needs to be 2 parentheses 1 plus H, parentheses 1 plus H.
2 times 5.
This is like, this needs to be multiplied out.
Yeah. So that's just this.
Yeah, but you should do it in the same step.
Five minus 2 is inside.
This should be, so this should be,
That's how it's shown.
Well, you can
Because
actually,
2 for the F.
you can do F one by, that just means
So
you plug
two-
it in.
Oh, okay.
times,
So don't straight out even have this.
2.
Well,
It's 2.
you need to have something here.
One, so it's 2
You can write
times
this,
2
or you can
minus
figure
1
out, like,
plus
what is
1.
that for one?
Okay, then
Two
the negatives there, so it's just simplifies to -1.
So, raise all this to -1.
No, raise this, and just have -1, and then this needs to be, just like this. This needs to be 1 plus H.
But that's one, so you just plug it in.
Maybe you just plug the 2 in for,
Yeah, that's it. And this stuff here should be. How's it going?
I'm like writing it out a lot, like every
Okay,
every
that's fine.
single thing. I don't know if I'm like on.
Yeah, unfortunately, it's having more complicated because there should be this one, there should be.
Yeah.
This is just F of one, which is times the
So just put 2.
two,
Okay.
minus one.
Okay. So yeah.
So we have a two of these things.
Pro-
This section.
Because I just want to go to the second page, but I guess.
You guys still good?
Yeah, I'm
You
going.
got three, yeah, start, three, great. 10. Nine.
No, it's the arithmetic college. It's the imagine, so you can
Yeah, that's right.
imagine.
So then we gotta simplify that. We have to expand.
Like those kids, like something special in their mind, their parents, like forced labor.
I probably is that.
I see
This is a five. This is two.
So I
Like when I
should
say
just
five,
do
that's
it.
right. When you see five minus two, you can't just subtract one minus two.
Okay. Okay.
right, can we go over these? I see some people have finished both of them, some people have not finished either of them. This is like I said before, these in my opinion are quite difficult. So if this seems hard to you, you know, I agree. This is hard. You shouldn't feel badly about that. We have plenty of time to get used to it. Let's try this one. So the very first step is often the hard step. That is plugging in to the function. So I am looking at the function you see on the top of the screen, 2x squared minus x, and I plug in. Well, I got this lim here. Plugging in, first of all, 1 plus h. You go up here. Every x I replace by 1 plus h. So it says 2, 1 plus h squared minus 1 plus h, like that. That was just this part. And then minus f of 1, which is, you go up here and you plug in 1. That I put in parentheses, 2 times 1 squared minus 1, all over h. So I believe I did that step properly. It looks easy when I do it, but you know, you could take 5 minutes thinking about that one step there, but that's how it's done. I'm a trained professional. All right, next we should, I guess, do the FOIL on the 1 plus h, since I don't see much else to do in this step. So I have 2, which I'll have to deal with later. 1 plus h, 1 plus h. And then maybe I'll distribute this minus sign here. Negative 1 plus h, so this is going to be minus 1 minus h. I hope you didn't forget those parentheses there. And then minus some stuff in these parentheses. Let's just do the numbers here. 1 squared is 1, so this is 2 times 1 minus 1. So that's 1, right? If you do your order of operations properly, that is 1. Okay, all over h. And now I'll do the FOIL thing. 2 times. The FOIL is 1, on the front it's 1 times 1, which is 1. In the middle it's h. On the outside it's also h, so this adds up to 2h. And then on the ends it's h times h, which is h squared. And then I got minus 1 minus h minus 1 over h. And finally distribute the 2, and I should be ready to start canceling everything out. So 2 plus 4h plus 2h squared minus 1 minus h minus 1 over h. Everybody with me so far? I hope so. Yeah, question?
So for the h at the end of like the FOIL, why are we now subtracting it rather than adding it? Because it's like
This h. Is that what you mean?
Yeah.
Yeah, there's kind of 2 of them. The one in the FOIL was always added and it ended up here.
Oh, okay.
This one over here is subtracted because here I distributed this minus sign.
Okay, thank you.
Yeah. All right, let's cancel the constants. I have 2 minus 1 minus 1, so they really do cancel. That's the step. This is usually the step at which you will know if you messed it up or not, because the constants either will or will not cancel. Usually if those constants cancel properly, then it means you're doing it correctly, although sometimes you can get it wrong even so. What remains is I have 4h and then another minus h, so that adds up to 3h plus 2h squared over h. And then finally, as we always do at the end, I factor h on top. 3 plus 2h over h, like so. And then we can cancel the h's. Don't cancel them before then. I end up with just 3 plus 2h. And we finish by plugging in the h equals 0. This is 3 plus 2 times 0 is 3. All right. Any thoughts about that one? I hope you got that. All right, and let's just do the other one. And I think maybe that'll do us for today. Since I'm tired, I got back last night at midnight. And I'm not used to staying up that late after traveling for 20 hours. So this one, I go f prime of 2. We begin with lim h goes to 0. Sorry, I didn't mean to scroll that thing away. It is f of 2 plus h minus f of 2 divided by h. That's the formula. you don't properly memorize the formula, you'll be screwed from the get-go. So make sure you do the formula properly. Common mistake is to put a plus in the middle instead of a minus. Sounds like a little thing, but it totally messes you up if you get it wrong. All right, anybody want to shout it out? What is f of 2 plus h? I know some people did this one, or even if you didn't. Someone want to say it proud? Say it loud?
5
Yes.
minus 2 parentheses 2 plus h
Mm-hmm.
plus 3 parentheses 2 plus h squared,
Excellent. Yeah.
and then parentheses that whole thing minus,
Okay, minus.
and star parentheses 5 minus 2 parentheses 2
All right.
plus 3 parentheses 2 squared and parentheses.
Great. We have here a parentheses lover. I love to see it. Yeah, this is what you should end up with. I wrote a little bit less parentheses than he said, but you know, this 2 times 2 is 4, right? The maybe confusing part is just this first one, but remember this comes from reading the formula for f, so it begins with a 5 and then a minus and then a 2 and then x, but instead of x I'm using 2 plus h, which is why it says 5 minus 2 and then 2 plus h. And then I see plus 3, which you see plus 3 here, and then instead of x squared I get 2 plus h squared. All right, great. Now we just need to do a bunch of expanding type stuff. So I will start with the 5. You can't do much with that. Distribute negative 2. It says minus 4 minus 2h. And then I have plus 3 times the FOIL, 2 plus h, 2 plus h. And then minus the numbers there. Did anybody do those numbers? What do you get inside the parentheses? 13. Anybody else get 13? Yes? I'm going with it. I'm not terribly good with the numbers, as you may know by now. That's not what it's all about, really. All right, 5 minus 4 minus 2h plus 3 times. Do the FOIL here. I get 4 plus 4h in the middle, and then h squared on the end. Minus 13 there over h. And then we just have to distribute the 3, and we'll be ready to start canceling everything out. 5 minus 4 minus 2h plus. Here I'm distributing the 3. 3 times 4 is 12. Now 3 times 4h is 12h. And then 3 times h squared is 3h squared. I hope I'm not going too fast here. Getting hot in here. Going so fast. All right, now we can hopefully cancel all the constants. For constants, I see 5 minus 4, which is 1, plus 12, that's 13, and then minus 13. So it all worked out as if a miracle. The constants all combined to 0. And then the rest of it you can add up. 3h squared just is going to stay like it is. I also have minus 2h and a plus 12h. They add up to plus 10h. So I got lim h goes to 0. 10h plus 3h squared over h. And now we do the usual thing at the end, which is factor the h on top and then cancel it. So factor h, what remains is 10 plus 3h over h. Cancel the h's. I end up with the limit of 10 plus 3h. Plug in h equals 0. I get 10 plus 3 times 0. 10 is the answer. It's quite a journey, but this is how it goes. Any last questions about that? All right. I see 10 minutes on the clock, but I think that'll do it for us. So we will have homework covering this stuff. It won't be a lot of questions, but you know, each question is going to take you several minutes to do, so check it out.